Okay, so we're talking about graphing absolute value functions. So those are shaped like a V. That's because if I plug 1 into my equation and I get 1 as an outcome, right? I can also plug -1 into my equation and get 1 as an outcome, right? Because if I take the absolute value of +1, that just means how far is 1 from 0, right? 1 unit away. Same thing with the absolute value of -1. That's only 1 unit away, correct? So when I put in 1, I get 1 as an outcome, and when I put in -1, I get 1 as an outcome. So it makes a V shape because it's symmetrical, right, on both sides. So if I'm like if I'm 1 away from my center to the right, then I'm 1 away from the center on the left, so on and so forth, okay? That's because when you plug something in, you'll always get 2 outcomes, okay, depending on the equation. So this is the parent function, just the absolute value of x. That's the most basic form of this function that you can get. So we are going to graph each of these functions and compare those graphs to the absolute value of x, and then we're going to describe what our domain and range is. So I've already put the absolute value of x, that graph, on your coordinate plane here, okay? And notice that it goes like diagonally to the corner, right? It's like up 1 over 1 on each side. All right, that's your basic one. What happens, this is going to go back to that previous lesson. What happens when I add 3 to the outside of the grouping symbols? What happens to my equation? Think back to the last lesson. It moves which direction? Up, right? Up or down? So that means that if I originally had a point here, then I would move that point 1, 2, 3 spaces up, right? Same thing here. If I have a point here, then I'm going to move that point 1, 2, 3 spaces up. If I have a point here, then I'm going to move that point 1, 2, 3 spaces up. And then I have to do that on the other side too, right? If I have a point here, I'm going to move that 1, 2, 3 spaces up. If I have a point here, 1, 2, 3 spaces up. So in other words, all that's happened is this equation, right, our original, just got moved 3 spaces up. So if I draw that line, see if I can get the right one here. I think it's this one. This would be the graph of the absolute value of x. This is the absolute value of x, right? Plus 3, meaning I just moved it 3 spaces up. Alternatively, you can also create a table of values. Now, it's faster if you already know what's happening. Now, is it always possible to really know what's happening or to just be able to move it up or down? Sometimes it stretches and shrinks and does all that stuff, right? However, let's say that I want to do a table. I'm really going to have to pay attention because you have to have some points. This is called your vertex, right? The like turning point of your absolute value equation. You have to have some points on the right of that vertex and some points on the left of that vertex, okay? So if I only picked numbers to plug in like 2, 3, 4, 5, then I'm only going to get this section of my graph, right? I have to have some points on this side and this side, and sometimes you don't know where it's at, right? But you can kind of gauge if you know what's happening with your equation. So I know if I'm adding 3 outside of these absolute value bars, that's going to move me up, right? So here's the thing. Let's say that I did do a table of values. I already know that I'm not stretching, I'm not shrinking, and I'm not moving to the left or right because there's nothing happening inside here. Then I can actually just pick some numbers to plug in. So let's say I do -2, -1, 0, 1, and 2. So we're going to plug in negative 2, negative 1, 0, 1, and 2. So let's say I do that. I'm going to plug in for this x value right here. So I've got absolute value of negative 2, and then I'm adding 3 to that, right? So when you work these out, you have to do the absolute value part first. So what's the absolute value of 2? That's 2, and if I add 3 to it, that gives me 5, correct? And if you look at where we put our point, negative 2, 1, 2, 3, 4, 5, right? Same thing with the negative 1. So if I take the absolute value of negative 1 and I add 3, what is the absolute value of negative 1? 1, and then I add 3 to that, that gives me 4. Look at where we have our point. Negative 1, 1, 2, 3, 4. Then you're going to do the same thing with 0. So the absolute value of 0 is 0, and if I add 3 to that, I get 3, correct? And then you're going to do the same thing with 1. The absolute value of 1 is 1, plus the 3 gives you 4. Look at where your point is. 1, 1, 2, 3, 4. And I want to point this out. Do you see how it was going down, 5, 4, 3, and now all of a sudden it's going back up? The next one's going to be 5, right? That's how you know that this middle part's your vertex, right? Because it's going down on this side and then back up on this side. So let's say that you didn't have that turning point. Then guess what? You either need to pick points on the opposite direction of that, where you were going. Let's say you'd only picked 1 and 2, right? 3, 4, 5 is just going to keep going up over here. You need to back up and probably pick some smaller x values, okay? And we'll get more into that as we get farther in. But is it not easier to just realize that this is going to go up 3 and to just take those and adjust them? So on this one, where is this one going? You're on the inside, right? So you'll do the opposite. This one's going to go to the right 2, correct? Since it's a minus sign, you go right. So if I have a point here, that means that I'm going to move that 2 spaces to the right. If I have a point here, I'm going to move that 2 spaces to the right. If I have a point here, I'm going to move that 2 spaces to the right. Let me zoom in so you can see that. All right, but that just gives me this right-hand side, correct? I still have to move these on the left. So if I have a point here and I move that 2 spaces to the right, now I have a point here, right? If I had this point and I move that 2 spaces to the right, now I'm here. And now I've got some points on either side, correct? So I can draw that in. You guys probably need some rulers. All right, so when we draw that in, we can see that we started with our parent function, right? And we moved it 2 to the right. But let's say that I wasn't sure. Maybe I didn't know if that was going to move 2 to the right or 2 to the left. Then I can make the table, correct? So let's say that I picked the ones I've been picking. So let's say I do the negative 2, negative 1, 0, 1, and 2. Let's see how this works out for us. All right, so I've got absolute value of x minus 2. So that would be plug in the negative 2 minus 2. And this is all in the absolute value, right? So I'll do that first. Negative 2 minus 2 is, so what is the absolute value of negative 4? 4. Positive 4, right? I'm 4 spaces from 0, so that's a 4. Then we'll do the same thing with negative 1. So negative 1 minus 2, that would give you the absolute value of negative 3, which is 3. All right, then we do 0. 0 minus 2 is, so the absolute value of negative 2 is 2. All right, then I do 1. 1 minus 2 is negative 1, and the absolute value of that is 1. And then I have the absolute value of 2 minus 2, which is, and the absolute value of 0 is 0. Now, if I plot those points, do you ever see it going back the other direction? 4, 3, 2, 1, 0. No, correct? Like, in other words, all I'm getting is this section right here, correct? You have to have the other side, correct? So it's easier for you to know if this is going to move left or right. So if you already know you're moving right 2, then that means you need to pick numbers that are going to be bigger than the 2, correct? So then when you plug in 3 minus 2 gives you 1, and the absolute value of 1 is 1. See how you turned? Then it's going to start going back up. So do you see the importance of picking the right points? So if you kind of know if it's going to move left or right, that will help you in deciding what numbers you need to pick. So if you don't have a plus or a minus inside here, it's not going to move left or right. Is everyone with me? Yes, no, yes, no. Now, when you start multiplying by stuff, sometimes it does shift it a little bit, but it won't shift it like way over. You know what I mean? So if all I had was adding 2 on the outside, then I could pick my normal negative 2, negative 1, 0, 1, 2. But if I'm going to shift to the right, then I need to shift my numbers to the right, correct? Maybe instead of starting at negative 2, I shift to this direction. Or if I already know that I'm just going to be moving, do I even need to do the table? No. But if you feel more comfortable, then you can. All right. So number 2. Now, number 2, I'm going to be stretching and shrinking, right? Because I'm multiplying by a number. So is this going to shift to the left or right? Like if I'm not adding to or subtracting to or anything like that, correct? So I'm going to go ahead and make a table, and I'm going to use my normal stuff. However, I want you to give this a little bit of thought when you think about the numbers that you're going to pick. Okay? It doesn't really matter when it's like a whole number, but when you have a fraction, then sometimes it's easier to pick certain numbers than it is other numbers. Does that make sense? Like if I'm going to multiply something by a half, then what are the only numbers that are going to end up with a whole number when you multiply by a half? Even numbers, right? Or if I'm multiplying by a third, then I would want to pick numbers that would divide by 3, right? Like 3, 6, 9, 12. Okay? So over here, I'm not multiplying by a fraction, so it doesn't really matter. So let's just pick our normal negative 2, negative 1, 0, 1, and 2. All right, so we're going to plug in. We have 2 times the absolute value of negative 2. So remember, you got to do this step by step. So you have 2 on the outside, and then what is the absolute value of negative 2? Positive 2. So now I have 2 times 2, which is 4. Everybody with me on this? Take care of that absolute value first before you put anything else with it. So now I have 2 times the absolute value of negative 1. That gives me 2 times, what is the absolute value of negative 1? 1. 2 times 1 is 2. Now I have 2 times the absolute value of 0. What is the absolute value of 0? 0. So 2 times 0 is 0. Now I do this again. 2 times the absolute value of positive 1. What is the absolute value of positive 1? 1. So 2 times 1 is 2. Did you find your center? Yes. What's the next one going to be? 4. So now I'm going to go up and plot those points. So negative 2, 1, 2, 3, 4. negative 1, 1, 2, and then your 0, 0, 1, 2, and then 2, 4. It just made it a little skinnier, right? Stretched it vertically. Make sure you put arrows on the end of your absolute values. Okay, any questions on that one? All right, so on this one, do we want to pick our normal -2, -1, 0? No, because we want things that are going to divide by this 2 right here, correct? All right, and it's negative. Is that right? I have a question. What do you think is going to happen when you have a negative that's being multiplied? It's probably going to flip, right? Upside down. So let's see what happens. So what do you think would be some good numbers for us to choose? I like to have 2 on the left and 2 on the right, and a 0. So I know I want to pick -2, right? Because that'll divide by 2. And then I'm going to skip -3 and I'm going to pick -4. So let's do -4, -2, 0, 2, and 4. Now, is it going to be wrong if you pick 1 or -3? No, you're just going to have decimals, right? Okay, so I have -1/2 times the absolute value of -4. So what's the absolute value of -4? 4. So that'll give me -1/2 times 4, which is -2. And you can do that in your calculator, right? You just can't do the absolute values in your calculator. All right, so now I have -1/2 times the absolute value of -2. So keep the -1/2. What's the absolute value of -2? 2. So if I take half of 2, that would just be 1, right? -1. Then I'm going to do the 0. So -1/2 times the absolute value of 0. That's just going to end up being what? 0. Then we do the same thing with 2. So -1/2 times the absolute value of 2. The absolute value of 2 is 2. So -1/2 times 2 is -1. And we have found our center, correct? So what is the 4 going to be? -2, right? So we'll plot our points. 1, 2, 3, 4, -2. And then -2, -1, 0, 0, 2, -1, and 4, -2. See how this made this a little bit wider, right? And were we correct? Did it flip it? Yes. All right, let's hop back to numbers 1 and 2 and talk about our domain and range, and we'll do that on both of those. All right, so it says describe the domain and range. Let's just describe the domain and range on both of them, okay? So let's talk about the original. That's the black one, right? So domain and range. All right, so remember domain is how far left and right, because those are your x values. What x values are encompassed in my graph? So if you look at this black graph, how far to the left is this going to go? Forever, right? Which is going to be -infinity all the way to +infinity. So you may just put all real numbers. Remember, that's 2 lines on the side, and then make your R. Okay? And then the range is how low does your graph go to how high. So what's the lowest that this graph goes? 0. So we're going to start at 0 and go how far up? How far up does the black graph go? Infinity. So we'll have a bracket. We start at 0, comma, go all the way to infinity. All right, so now let's talk about our f of x, right? We'll just call it f of x. All right, your domain, that's how far left and right, all of the x values. So how far left and right does your pink graph go? Negative infinity to positive infinity. So that would be all real numbers. All right, but we moved this graph up, correct? So now instead of going all the way down to 0, it's only going down to 3, correct? So we have a bracket. We start at 3, and how far up does it go? Infinity. Close that with a parenthesis. This is the only one we're going to do the original on because the original is the same for all of them, right? At least on these they are. Okay, so let's talk domain and range for your pink graph over here. How far left to how far right does your pink graph go? Negative infinity all the way to positive infinity. Are you seeing a pattern here? All right, so all real numbers. For your range, that's how low does this graph go to how high. So what's the lowest this pink graph goes? 0 all the way to infinity. So you've got a bracket, 0, comma, infinity. All right, so look at number 2. All right, part A, for your domain, how far left to how far right? All right, negative infinity to positive infinity. And then for your range, how low? How low is this? 0 to infinity. All right, so for domain, we have all real numbers. And for your range, 0 to infinity. And what about for part B? We've got domain. How far left to how far right? All right, so that would be all real numbers. But the range is going to be a little different because we're not starting at a number. We're starting at negative infinity, and it has a high point, right? So this would be negative infinity all the way up to 0. So you're going to be backwards a little bit. So you've got negative infinity all the way to 0 bracket. So if it has a high point, then you're going to be at negative infinity to a number, right? If it has a low point, then it'll be that low point to infinity. So make sure you put them in the right spots. All right, so number 3. Again, I've already put that on your paper, this one, okay? And then we have t of x. So multiplying by a negative is going to make this do what? Flip. And then multiplying by the 3 is going to make it either shrink or stretch, correct? Okay, so is it going to move left or right at all? No. So when we make our table, we can pick the normal -2, -1, 0, 1, and 2. All right, so let's do our plugging in. So we have negative 3 times the absolute value of, and then we plug in our negative 2. So before I multiply, I have to take care of the absolute value, so I keep that negative 3. What is the absolute value of negative 2? 2, and when I multiply that, I get negative 6. All right, same thing with the negative 1. Negative 3 times the absolute value of negative 1. So I have negative 3 times, what is the absolute value of negative 1? So negative 3 times 1 is negative 3. Then I've got negative 3 times the absolute value of 0, which is going to end up being 0, right? Then I do the 1, so negative 3 times the absolute value of 1. What is the absolute value of 1? 1. So I have negative 3 times 1 is negative 3, and now you've turned, correct? So the next one will be negative 6, as long as you're equally distanced away, right? From 2 spaces away, 2 spaces away. So I'm going to plot those points. I've got negative 2, 1, 2, 3, 4, 5, 6, and negative 1, negative 3, 0, 0, 1, 3, 2, negative 6. Okay, so let's talk about your domain and range for the pink one. Domain and range. How far left to how far right is this graph going? All right, so all real numbers. And your range, you're starting down, right? It's always how far down and then meet at the top. So this will be negative infinity to 0. So parentheses, negative infinity, comma, 0 with a bracket. All right, now we're going to start with something that is not your parent function and then graph something that is. So you may want to use 2 different colors so you can tell the difference between the 2. All right, so let's start with the f of x. I'm going to do this one in pink. You can use whatever color you want. All right, so before you start, remember it's always good to decide if you're going to be shifting to the right or to the left. So remember, your original equation is always this, right? That's at the center. When you change things, that's when it moves, okay? So, did this graph move left or right? It moves to the left, right? Look inside here and you see that you're adding 2. That means you're going to move left, which means we don't really want to pick numbers over here, right? We normally pick as far as 2, but we might want to shift that 2 to the left and make 0 the farthest we pick to the right. Does that make sense? All right, and we also know that it's going to move down 3, correct? So in other words, we normally have a vertex here. It's going to move left 2 and down 3. Now, we could just move it, right? From what would be an original, which is just goes diagonally. You could take that point and move it 2 left and 3 down. Or you can pick the points, okay? And let's face it, when we start multiplying, you can't do that just because you don't know how far it's shifting up, right, with the stretch or the shrink. So we're going to go ahead and practice doing the table anyways. But if you knew, you could just move it. All right, so we already stated that we're moving 2 to the left, so normally negative 2 is as far to the left as I pick, so I'm going to move that 2 more over and go with negative 4, negative 3, negative 2, negative 1, and then 0. I always want you to have like 5 points, right? 2 on each side and 1 in the center. And I'm going to go ahead and plug in. So I have negative 4 plus 2, the absolute value of that, minus 3. So what is negative 4 plus 2? It's negative 2, right? And if I take the absolute value of negative 2, I get positive 2. Minus the 3 gives me negative 1. All right, then I do the negative 3. So absolute value of negative 3 plus 2. So do inside your absolute value first. Negative 3 plus 2 is negative 1. If I take the absolute value of negative 1, that gives me 1. Take away 3 gives me negative 2. Do the same thing with your negative 2. Negative 2 plus 2, what's the absolute value of, that would be 0, right? And 0 minus 3 is negative 3. Then do the same thing with your negative 1. Negative 1 plus 2 is 1. What's the absolute value of 1? 1, and 1 minus 3 is negative 2. You've turned. Do you see that? So then the next one will be negative 1. So we're going to plot those points. 1, 2, 3, 4. Negative 1. Negative 3, negative 2. 3. And then draw that in. All right. Now that we have that on the graph, we're going to look at the second one. So pick another color. I'm going to go with blue. So this is g of x. Two x plus 2 minus 3. So if you look between this graph and this graph, the only thing that's different is I'm multiplying by a 2 here. So I'm still shifting left and down, right? But now I'm going to make it either skinnier or wider, right? Just depending on where we've multiplied by. So I'm stretching or shrinking. So I'm going to stick with the same numbers, and then if we have to adjust, we can. I think this one, because we're multiplying and adding at the same time, it might pull that vertex up just a little bit. We'll just have to see. So we have our negative 4, negative 3, negative 2, negative 1, and 0. So I have 2 times negative 4 plus 2 minus 3. So if you plug this in your calculator, you can't plug in the absolute value, but you can plug in this number, you get negative 6. Then just take the absolute value of that number. You get 6 minus 3 gives you 3. And here's the thing, if it gives you a negative 6 in the calculator, you already know that it's going to be positive 6, right? So just give it a little thought. All right, same thing with 2 times negative 3 plus 2. And if you don't want to have to type that all back out again, if you just go up and press enter, then you can arrow over and just type over that 4 and make it a 3. All right, so that gives you negative 4, which means you're going to take the absolute value of that, which gives you positive 4 minus 3 is 1. Then we'll do negative 2, so 2 times negative 2 plus 2, and then the minus 3. So that's going to give you negative 4 plus 2 is negative 2, so you get 2 minus 3, which is negative 1. Then you do the same thing with negative 1. 2 times negative 1 plus 2, and then minus 3. So negative 2 plus 2 is 0, and 0 minus 3 is negative 3. Notice we have not turned yet, correct? We're still on our way down, so we're waiting to come back up. So I've got 2 times 0 plus 2 minus 3. So inside here is going to give us 2. The absolute value of 2 is 2 minus 3 is negative 1. We've turned, right? Now we're headed back up. And if you want to add another one to that side, you could, because if you did 1, what's the number going to be? 1, right? As long as you're going up the same amount here, it'll mirror this right here. So if I've got negative 3 in the center, and then I have the negative 1s, and then the 1s. So if I did 2, then it would be a 3, right? Because it's going to be the same on either side. All right, so I'm going to plot my points. I have negative 4, positive 3, negative 3, positive 1, don't leave if the bell rings, negative 2, negative 1, negative 1, negative 3, and then I started going back up. So draw your line in. And then we'll go over the difference and compare them in the next time.